Now we're going to look at our titration of a strong acid and a strong base just before the equivalence point. So we're going to find out here in a little bit that at 50 milliliters we will have reached our equivalence point. So here we are just before the equivalence point. And now we're going to calculate the pH. So once again, we can say that the concentration of HCl is going to be equal to the concentration of hydronium, because HCl is a strong acid, so the concentration of hydronium is going to be 0.1. And we can also say the same thing about our concentration of our hydroxide, because sodium hydroxide is a strong base. The concentration of hydronium is going to be equal to 0.1. So we remember that this reaction between our strong acid and strong base is going to be a neutralization. So the first thing that we need to do is convert to moles. So we have our concentration of our acid and base, and we multiply by the number of liters to get the number of moles of each species. And remember, at this point, one of the first things we want to do is see where we're at in our titration curve, confirm that. And the way we do that is by comparing the number of moles of hydronium and the number of moles of hydroxide. So here the number of moles of hydroxide are less than the number of moles of hydronium that we started with, so that means we are before the equivalence point. So because we're before the equivalence point, what we want to do is to find out how many moles of hydronium are left over. So with this, we understand that hydroxide reacts with hydronium. So if we start with 5 times 10 to the minus third moles of hydronium, and we understand for each mole of hydroxide we use up 1 mole of hydronium, and we subtract that off here, what we're left with is the number of hydronium moles of hydronium that we have left over. So after we subtract off the number of moles of hydronium that's used up by hydroxide, and then remember that's a 1-to-1 mole ratio, so for every 1 mole of hydroxide we add, we use up 1 mole of hydronium. We started with a certain amount of hydronium, we've used up a certain amount of hydronium, and now what we have left is a certain number of moles of hydronium. Once again, we want to divide by the volume total. So we have moles of hydronium, but what we want is the concentration of hydronium. Here, the final volume is going to be equal to the 50 milliliters of acid that we started with. So we started this titration with 50 milliliters of our acid, and then we added 49 milliliters of our base. So with this, we totally have in total we have 99 milliliters, or 0.099 liters. So if we take the number of moles of hydronium we have left over, divide by the volume total, this gives us our new concentration of hydronium after we've added in our base. We then take this number, plug it into our pH equation, so we take the negative log of our concentration of hydronium, and then this gives us the pH. So notice, even now, we're 1 milliliter away from the equivalence point, our pH is still 3. And notice what happens now. We're going to add 1 more milliliter and then another milliliter after that. So between 0 and 49 milliliters, our pH has gone from 1 to 3. And now watch what happens after we add in a couple more milliliters of our sodium hydroxide.